Terms to express the concentration of solutions. A solution is a homogeneous mixture. Solution is a homogeneous mixture of two or more substances. Homogeneous mixture of two or more substances that are called components. The solution containing only two components is called a binary solution. Let us study some binary solutions. In the case of a binary solution, the component that is present in large quantity is called, solvent, and the components present in small quantity is called solute. So, the component that is present in large quantity is called a solvent, and component that is present in small quantity is called a solute. When we put some sugar into a glass full of water, then sugar is the solute and water is the solvent. The resultant is called solution. Okay. Now, the first term used to express the concentration of the solution is mass percentage. Mass percentage. Mass fraction and mass percentage. Mass fraction and mass percentage. Now, what is mass fraction? Consider a solution containing two components, A and B. Let their masses be WA and WB. WA is the mass of A, WB the mass of component B. Now, we can say that mass fraction of A in the solution is equal to mass of A by total mass, that is WA plus WB. Mass fraction of A is equal to WA by WA plus WB, where WA is the mass of A, WB is the mass of B. Similarly, mass fraction of B is equal to WB by WA plus WB. See, now we can say that mass percentage. What is mass percentage of A? See, mass percentage of A is equal to, see, mass fraction into 100. That is WA by WA plus WB the whole into 100. You will get the mass percentage of A. Now, what is the mass percentage of B? Mass percentage of B is equal to mass percentage of B is equal to WB by WA plus WB the whole into 100. See, this is mass percentage of B. So, mass percentage is mass by mass percentage. For example, 0.9% solution of urea in water means 0.9% solution of urea in water means, see, 0.9% W by W. Urea in water means 0.9 gram of urea is present in 100 gram of the solution. The second term is molarity. M-O-L-A-R-I-T-Y. Molarity. Denoted by capital M. Molarity. Symbolized by capital M. Molarity of a solution is defined as number of moles of solute present in, number of moles of solutes present in 1 liter solution. Note it, number of moles of the solute present in 1 liter solution. See, 1 m NaOH means 1 m NaOH means it's written as 1 m NaOH and it is read as 1 molar. NaOH means 1 mole of NaOH is 1 mole of NaOH is dissolved in 1 liter solution or present in 1 liter solution. See, 1 molar NaOH means 1 mole of NaOH is present in 1 liter of the solution. You know that 1 mole of NaOH is GMM, gram molecular mass. Sodium, it's 23. Oxygen, 16 and hydrogen, 1. So, it is 40. So, 40 gram is present in 1 liter of the solution. It is 1 molar. Now, what is semimolar? Semimolar. Semimolar means 0.5 molar, half. Now, what is centimolar? Sorry, decimolar. Decimolar means 0.1 molar. It is decimolar. And what is centimolar? Centimolar. It is 0.01 molar. That is 1 by 100 molar. This is 1 by 10 molar. This is 1 by 2 molar. 1 by 2 molar, 1 by 10 molar and 1 by 100 molar. M, capital M. All are capital M. Okay. This is what is called molarity. Now, how can we calculate molarity? Molarity is, according to definition, molarity is the number of moles of the solute present in 1 liter of the solution. So, its formula is NB, N subscript to B. B stands for solute. So, NB means number of moles of the solute by volume of the solution in liter. NB by V. Here, M is molarity. NB is number of moles of the solute. Number of moles of solute. Then V is the volume of the solution. Volume of solution in liter. See, you know that NB means number of moles of the solute. It can be expressed as WB by MB. That is mass by molecular mass. Mass of B by molecular mass of B. So, we can substitute here. We get M is equal to, capital M is equal to WB by MB into V. WB by MB into V. See, V is the volume in liter. Now, making it in milliliter, we have to multiply it with 1000. So, the most user-friendly formula is M is equal to WB into 1000 divided by MB into V, where M is the molarity. What is the unit of molarity? Mole per kilo, mole per liter, mole per liter. Mole per liter is the unit of molarity. Number of moles in 1 liter of the solution. So, mole per liter. WB is the mass of the substance in grams. WB is the mass of the substance in grams. WB, mass of solute in gram. MB is the molar mass or molecular mass of solute. And you know its unit is in gram per mole. Now what is V? V is the volume of solution in milliliter or centimeter cube. Why? Because there is 1000. If there is no 1000 here in the numerator, then V is in liter. But here there is 1000 in the numerator, so V is in milliliter. This is the formula that is used for making molarity. Let us calculate some problems based on this term. That is what is called molarity. Question. calculate the molarity of a solution prepared by dissolving 2 gram of NaOH, 2 gram of NaOH in sufficient quantity of water to get 250 ml solution. Repeat. Calculate the molarity of a solution prepared by dissolving 2 gram of NaOH in sufficient quantity of water to get 250 ml solution. We are asked to find molarity. So, molarity can be determined using the formula M is equal to WB by MB into V the whole into 1000. See, this is the formula used for finding molarity. Now, we are going to write down the data given in the problem. WB means mass of the solute. Here, B stands for solute. The mass of the solute, sodium hydroxide, is 2 grams. Okay. Then, molecular mass of the solute, MB. Sodium hydroxide, for sodium hydroxide, 23 sodium, oxygen 16, hydrogen 1, so we get 40. So, 40 gram per mole is the molecular mass of sodium hydroxide. Then V, what is V? 250 milliliter. V is 250 milliliter. See, volume is given in milliliters, so that is why we use this formula. If volume is given in liter, we don't write 1000 here. We write only W by MB into V, because V is volume in liter there. Here it is in milliliter. We have to multiply 1000 in the numerator. So, substituting these values here, 2 into 1000 divided by 40 into 250. See, this is 4. So, it's given by, it is 10, 2 by 10, that is equal to 0.2 here. Therefore, the molarity of the solution is 2 mole per liter. Mole per liter, the unit of molarity. So, 2.2 mole per liter. 0.2 mole per liter is the molarity of thus obtained solution. Okay. Some more problems in molarity. Question. If you dilute 300 milliliter 4 molar NaOH solution to 900 milliliter, what will be the new molarity of the solution? Molarity of the solution. See, if you dilute 300 milliliter of 4 molar NaOH solution to 900 milliliter, what will be the new molarity of the solution? That is the question. See, here there is a solution of volume 300 milli with a molarity 4. And we are asked to dilute the solution to 900 milliliter. Then what will be the new molarity after diluting? For doing this problem, we can use this formula M1V1 is equal to M2V2, where M1 is initial molarity, V1 is initial volume, M2 is final molarity and V2 is final oleum. Substituting the values here, 4 into 300. So this is V1, this is M1 is equal to M2, which is to be determined. Then V2, it is 900 milliliter. So it is 900 milliliter. We can find M2 here. M2 is equal to 4 into 300 divided by 900. 4 into 300 divided by 900. That is M2. See, this is 3, 4 by 3, and it is equal to 1.33. So, molarity of the new solution is 1.33 mole per liter. See, that is the molarity of the new solution. Now we can do another question. See, calculate molarity of pure water. Pure water. Calculate molarity of pure water. We know that the mass of 1 liter or 1000 milliliter water is equal to volume into density. We know the volume of water is 1000 milliliter. Density is 1 gram per milli. 1 gram per milli. See, milliliter cancels off. We get 1000 gram. That is the mass of 1000 milli water. Now, the number of moles of water present in 1000 milli water. That is molarity of water. Molarity of water. See, this is given by mass by molecular mass. That is mass 1000 divided by molecular mass is 18. Its value is 55.556. 55.56. So, molarity of pure water is 55.56 mole per liter. Okay, that is molarity of pure water. That's all. Now, molality of a solution. Molality, not the spelling, M-O-L-A-L-I-T-Y. Previously it was molarity, R-I-T-Y. This is L-I-T-Y, molality. It's denoted by small m. Previously it was capital M. Okay. What is molality? Molality of a solution is defined as the number of moles of solute present in 1 kilogram or 1000 gram solvent. 1 kilogram solvent. Previously it was in 1 liter solution, but here it is 1 kilogram or 1000 gram solvent. So, molality is defined as the number of moles of the solute present in 1 kilogram of the solvent. See, 1 small m H2SO4 means it is read as 1 molal sulfuric acid, H2SO4. And it means 1 mole of H2SO4 is present present in 1 kilogram water or solvent. 1 kilogram water or solvent. Okay. That means 1 mole means sulfuric acid, 1 mole means hydrogen 2, sulfur 32, and oxygen 4. 16 into 4 is equal to 64. So it is 8, 9, 98. That is 98 gram sulfuric acid is present in 1 kilogram of water. That is what is called 1 molal solution. 1 molal solution of sulfuric acid. So unit of molality is mole per kilogram. According to the definition itself, the unit of molality is mole per kilograms. Molarity is mole per liter. This is mole per kilogram. Okay. Now what is the formula used for finding molality? Small m, molality is equal to number of moles of the solute present in 1 kilogram of the solvent. See, B stands for the solute and A stands for the solvent in a binary solution. So NB by WA, where NB is the number of moles of the solute, number of moles of solute, and WA is the mass of the solvent in kg. See, we know that NB, number of moles of the solute, is equal to WB by MB. Substituting this value here, small m is equal to WB by MB into WA. See, WA is the mass of the solvent in kilograms. By changing the mass in grams, we have to put 1000 here or multiply 1000 in the numerator. So this is the most user-friendly formula used for finding molarity, where M is molality in mole per kilograms. WB, mass of the solute in grams, mass of solute in grams. WA, mass of solvent in grams. See, if there was no 1000 or if there is no 1000, then mass in kilograms. But here we put 1000 here, so mass will be converted into grams. And the MB, molecular mass or molar mass of the solute in gram per mole. So this is the formula used for finding molality. Let us check which term is most useful. See, molarity that we have studied previously, molarity is WB into 1000 divided by MB into V. You know that WB mass of the solute, MB molecular mass of the solute, V is the volume of the solution in milliliter. Now, molality, small m, is equal to WB into 1000 divided by MB into WA. See, molarity, this is rity, depends on volume. It changes inversely with the volume. And molality, depends on mass. It changes inversely with the mass. See, so molarity may change with the change in volume, and molality will not change with the change in volume. It depends on mass, and this depends on volume. So molality may change from place to place where temperature changes, but molality does not. Why? Because volume of a solution changes with a change in temperature, but mass does not change with a change in temperature. Therefore, molality is most useful term, most dependable term to express the concentration of the solutions. Problem. Question. The density of 3 molar NaCl solution is 1.25 gram per milliliter. Calculate its molality. See, the density of 3 molar NaCl solution is given. It is 1.25 gram per milli. 3 molar. And we are asked to find molality. So, we are supplied with molarity and density. And we are asked to find molality. A special type of problem by which is asked for converting molarity to molality. Okay. First of all, we are going to calculate the mass of 3 moles of sodium chloride, because 3 molar means 3 moles in 1 liter of the solution. So mass of 3 moles of sodium chloride, mass of 3 moles of NaCl is equal to 3 into molecular mass, that is 58.5. 3 into 58.5. See, sodium 23, in the case of sodium chloride, sodium 23, chlorine 35.5, so 58.5, that is the molecular mass of sodium chloride. So 3 into 58.5 is equal to 175.5 grams per mole. Grams. 3 moles. For 3 moles it is 175.5 grams. Now mass of solution is equal to, mass of 3 molar solution is equal to, 3 molar means 3 moles in 1 liter of the solution. So mass of solution is equal to volume into density. See, volume is 1000 milli. Why? Because 3 molar solution means 3 moles per liter. 3 moles in 1000 milli. So 1000 milli into density is 1.25 gram per milli. Gram into milliliter raised to minus 1. So milliliter raised to minus 1 cancels off. We get 1250. 1.25 into 1000 is equal to 1250 grams. That is the mass of 3 molar NaCl solution. And the mass of 3 mole sodium chloride solute is 175.5. This is the mass of the solute. This is the mass of the solution. So, if we minus or we subtract 175.5 from 1250, we will get the mass of the solvent. So, mass of solvent means water. Mass of water is equal to 1250 minus 175.5. 1250 minus 175.5 is equal to 547. See, 1074.5. 1074.5 grams. This is the mass of the solvent. Now, molality of the solution small m is equal to WB into 1000 divided by MB into WA. Okay. See, data. As we have calculated here, WB, mass of the solute, is 3 mole sodium chloride, that is WB is equal to 175.5 grams. Molecular mass of the solute, MB, is equal to 58.5. This 58.5 grams per mole. Now, WA, mass of the solvent, that we have calculated here, that is 1074.5. 1074.5 is the mass of the solvent. So 1074.5 is the mass of the solvent. Substituting here, see, WB is 175.5 into 1000 divided by molecular mass is 58.5 into WA is 1074.5. The answer can be expressed as 2.791 mole per kilograms. Mole per kilograms. This is the value, that is molality of 3 molar NaCl solution. Okay. Let us learn a new term called mole fraction. Chai. See, chai. Consider a solution containing 2 components, A and B. Let Na be the number of moles of A and Nb be the number of moles of B. Then we can say that mole fraction of A, that is chai A is equal to Na by Na plus Nb. Similarly, mole fraction of B, chai B is equal to, mole fraction of B, chai B is equal to Nb by Na plus Nb. If there is a third component C, then mole fraction of A will be Na plus Nb plus Nc, and so on. See, for ith component, chai I is equal to, ith component, chai I is equal to Ni, number of mole of ith component, divided by N total number of moles. This is the general formula used for finding mole fraction. Now, chai A plus chai B is equal to Na by Na plus Nb plus Nb by Na plus Nb is equal to 1. So, mole fraction, sum of the mole fractions of all the components in the solution must be equal to 1. That is unity. Now, mole percentage can be calculated using the formula mole percentage is equal to mole fraction into 100. Chai I means mole fraction of the ith component, any component, into 100. If mole percentage of A is to be calculated, then chai A into 100. B is to be calculated, chai B into 100, and so on. This is the general formula, that is percentage of the mole percentage of the component is equal to mole fraction into 100. Okay. Now we can do a problem here based on this mole fraction. We have a mixture of methanol and ethanol. See, it contains 96 gram of methanol and 92 gram of ethanol. A solution contain 96 gram of methanol and 92 gram of ethanol. Calculate mole fractions and mole percentages of methanol and ethanol. See, a solution contains 96 gram of methyl alcohol or methanol, 92 gram of ethyl alcohol or ethanol. Calculate the mole fractions of both, that is methanol and ethanol, and mole percentages of methanol and ethanol. Okay, we are asked to calculate the mole fraction of methanol and ethanol and their mole percentages. Now, first of all, we have to calculate the number of moles. Here we are supplied with only mass. So, number of mole of methanol is equal to mass of methanol by molecular mass. See, mass of methanol is 96. Now, what is the molecular mass of methanol? Methanol, carbon 12, hydrogen 4, oxygen 16. So, 32. That is, molecular mass of methanol is 32. So, 96 by 32 is equal to 3. Therefore, number of moles of methanol in the solution is 3. Similarly, we can calculate the number of moles of ethanol, C2H5OH, NC2H5OH, number of moles of C2H5OH. It's also calculated using the formula W by M. That is equal to mass of the ethanol in the solution is 92 by molecular mass. See, ethanol, carbon, there are 2 carbon atoms, so 24. There are 6 hydrogen atoms, 6, and there is 1 oxygen atom, 16. Therefore, 16, one reminder, 46. So, molecular mass of ethanol is 46. (92 by 46 is equal to 2. See, this is the number of moles of ethanol in the solution. Now, mole fraction of methanol CHI-CH3OH is equal to number of moles of methanol by number of moles of methanol plus number of moles of ethanol. Am I right? So, it's equal to number of mole of methanol is 3 by number of mole of methanol is 3 plus number of mole of ethanol is 2. That is 3 by 5. That is equal to 0.6. See, this is the mole fraction of methanol. Now, let us find mole fraction of ethanol, CHI-C2S5OH is equal to NC2S5OH divided by NCS3OH plus NC2S5OH. That is, number of mole of ethanol is 2. So, 2 divided by number of mole of methanol is 3. 3 plus 2, that is 2 by 5, that is equal to 0.4. So, we got mole fraction of methanol and a mole fraction of ethanol. Now, we are also asked to find the mole percentage. See, mole percentage of methanol is equal to CH3OH is equal to mole fraction of methanol into 100. That is equal to, see, 0.6 into 100. That is 60. Similarly, mole percentage of ethanol is equal to mole fraction of ethanol, that is chai C2S5OH into 100. That is equal to 0.4 into 100 is equal to 40%. 40% or 40. That is the mole percentage of ethanol. That's all about mole fraction.